It's a plane that shouldn't exist, a narrow-body jet streaking across the Atlantic for 11 hours straight, landing in cities that were once thousands of miles out of reach. This is the Airbus A321 XLR, the aircraft that promised to upend the airline industry. But while airlines were placing billions of dollars in orders, safety regulators were sounding an alarm. They'd found a single, catastrophic flaw in the design. A flaw that could turn a survivable accident into an inferno. Why was this game-changing jet almost derailed before its first flight? And how did the fix compromise the very performance that made it so special? To understand the A321 XLR, you first have to understand the problem it was built to solve. For years, the aviation world had a gap, a hole in the market left by the retirement of one of the most versatile planes ever built, the Boeing 757. That jet had a unique talent. It was small enough to be efficient, but had long enough legs to connect smaller cities across the Atlantic. When it was gone, airlines were left with a tough choice: fly a half-empty wide-body jet and lose money, or don't fly the route at all. This was the middle-of-the-market problem. Airbus saw an opportunity. Their first attempt, the A321LR or long range, was a good plane, but it wasn't the final answer. It used extra fuel tanks stored in the cargo hold, but on the toughest transatlantic flights, especially flying west against fierce winter headwinds, it was pushed to its absolute limit. Sometimes, it couldn't even make the trip without cutting down on passengers or making an unplanned fuel stop. The market needed something more. Enter the A321 XLR, the extra long range. This wasn't just an upgrade, it was a reimagining of what a narrow-body jet could do. Airbus promised a staggering range of 4,700 nautical miles. That's enough to fly from New York to Rome or Delhi to London. These were routes that were the exclusive territory of giant, expensive jets like the Boeing 787 or the Airbus A350. The XLR promised to do it with 30% lower fuel burn per seat. It was a license for airlines to print money, opening up hundreds of new direct routes between cities that had never been connected before. The secret to this incredible performance was a single engineering breakthrough: the rear center tank, or RCT. Unlike the removable tanks in the older LR model, the RCT was a permanent, massive fuel tank built directly into the structure of the aircraft itself. It was a brilliant, elegant solution that made maximum use of space, giving the plane the fuel it needed without sacrificing too much cargo capacity. The response from the industry was explosive. Over 500 orders flooded in from more than 25 airlines. It was a massive vote of confidence. The A321 XLR wasn't just a plane, it was the future of long-haul travel. But here's where the story takes a dark turn. The thing nobody tells you is that when you push engineering to the absolute edge, you sometimes cross a line you can't see, and the line Airbus crossed was about to be pointed out by the last people they ever expected. In the world of aviation, regulations are written in the lessons of past disasters. The rulebook is designed around what regulators know: fuel tanks in the wings or separate, well-protected tanks in the cargo hold. The A321 XLR's rear center tank was neither. It was something entirely new, a novel and unusual design feature, and that phrase is a major red flag for safety agencies. Because the RCT was integrated into the airframe, the plane's thin aluminum skin was also the outer wall of a tank holding nearly 13,000 liters of jet fuel. This design had never been certified before. Regulators at the European Union Aviation Safety Agency, or EASA, began to ask tough questions. What happens in a survivable crash? Not a catastrophic event, but a gear collapse on landing, or the plane skidding off the runway. Their focus zoomed in on one specific, terrifying scenario: a post-crash ground fire. Imagine a pool of spilled fuel igniting underneath the aircraft. For a normal plane, the fire would have to burn through the fuselage, then insulation, then a cargo liner before it even got close to a separate fuel tank. There are layers of protection. On the A321 XLR, those layers didn't exist. The fire would be burning directly on the wall of the fuel tank. The risk was a burn-through, a breach that would introduce fire directly into a massive reservoir of fuel, turning a survivable situation into an unsurvivable inferno. It would drastically reduce the time passengers and crew had to escape. Usual move. Airbus's biggest rival, Boeing, formally submitted a document to EASA outlining its own safety concerns. This wasn't just corporate gamesmanship. Boeing's engineers pointed out the exact same flaw, stating that a fuel tank integral to the airframe inherently provide less redundancy and could lead to more hazardous outcomes. They argued that even a simple gear failure could rupture the tank. It was a stunning public rebuke, and it validated every fear the regulators had. ESA publicly agreed with Boeing's assessment. The problem was real, and the pressure on Airbus was now immense. But here's where it gets even crazier. This was all happening in a post-737 MAX world. The entire aviation industry was operating under a microscope of intense scrutiny. The days of regulators trusting manufacturers to get it right were over. Airbus wasn't just facing a technical challenge, they were facing a crisis of trust, and the authorities were in no mood to give them the benefit of the doubt. Faced with a design that the rulebook couldn't cover, the regulators didn't ban the plane. They did something much more difficult. They wrote a new rulebook just for the A321 XLR. They created a set of special conditions, bespoke safety standards, designed to make this novel design as safe as a conventional one. The core of these new rules was all about fire. The entire lower section of the fuselage around the tank had to be resistant to fire penetration, but the US Federal Aviation Administration, the FAA, took it a step further. They put a number on it, a hard, non-negotiable target. Airbus had to prove that in a ground fire, the fuel vapors inside the tank would not ignite for at least 5 minutes. That might not sound like a long time, but in an emergency evacuation, it's an eternity. It's the window of time needed to get every single person off the plane. The FAA wasn't asking Airbus to try. They were giving them a direct order. This changed everything. Airbus now had a clear, brutally difficult target to hit. Their engineers were forced back to the drawing board in a high-stakes race against the clock. The solution was a complex, multi-layered defense. First, they changed the materials, building the tank from an advanced aluminum-lithium alloy that was much better at resisting high temperatures. Second, they added more structure, reinforcing the airframe around the tank to protect it from impacts during a belly landing or gear collapse. But the most critical changes were the new layers of protection. They added a protective inner liner to the tank, a secondary barrier designed to contain fuel even if the outer wall was punctured, and most importantly, they developed a new specialized package of fire-retardant insulation to wrap around the tank, creating the thermal barrier that was missing in the original design. Developing these fixes was one thing, proving they worked was another. Airbus used powerful supercomputers to run thousands of digital simulations, modeling how fire would behave. But simulations weren't enough. To satisfy the regulators, they had to do it for real. In test facilities, representative sections of the redesigned fuselage were subjected to intense, live fire tests. Imagine a piece of a brand new, multi-million-dollar jet being deliberately set ablaze, with engineers and regulators watching the clock, waiting to see if the design would hold for those 5 critical minutes. The tests worked. The design was safe. Airbus had a fix. But what many overlooked is that in aviation, safety always comes at a price. And the bill for the A321 XLR was about to come due, paid in the 2 currencies that matter most: weight and time. Every single fix Airbus added to the A321 XLR came with a penalty: weight. The stronger materials, the extra structural supports, the inner liner, the fireproof insulation, it all added up. Industry sources estimate the final redesign added between 700 and 800 kilograms to the plane's empty weight. In aerospace, that's a massive increase. An extra 800 kilograms is like permanently carrying around 5 extra passengers and all their luggage on every single flight. And that extra weight has a direct, unavoidable consequence. It kills range. The more the plane weighs, the more fuel it has to burn just to carry itself, leaving less fuel to push it across the globe. Analysts calculated that the weight penalty would slash the A321 XLR's maximum range by at least 200 nautical miles. Suddenly, that magic number of 4,700 nautical miles was a marketing dream, not an operational reality. Early data from the launch customer, Iberia, shows a real-world maximum range closer to 3,920 nautical miles. The plane could still fly incredible distances, but the longest, most ambitious routes it was designed for were now potentially out of reach. The second price was time. The redesign, testing, and certification process took years. The plane was originally supposed to enter service in late 2023. That date was pushed to the middle of 2024, but even that was just the official program delay. For the airlines, the wait was even longer. United Airlines, which had planned its future network around the jet, now doesn't expect its first one until 2026, a 3-year delay. American Airlines has its first plane, but it's stuck on the ground in Germany, not because of the fuel tank, but because of separate delays with its custom business class seats. This created a domino effect. Airlines had to scrap their plans. New routes were put on hold. Old, inefficient Boeing 757s that were supposed to be retired had to be kept flying, costing millions in extra maintenance and fuel. So the game changer finally arrived, but it was late, heavier, and shorter-legged than promised. But was it still a game changer, or was the revolution just a compromised evolution? But here's the most shocking fact. Even with these penalties, the A321 XLR is still in a class of its own. Its only real competitor in the narrowbody market is the Boeing 737 MAX 10. But that plane's maximum range is barely 3,000 nautical miles. The compromised XLR can still fly nearly 1,000 nautical miles further. It still holds a monopoly on the mission it was designed for, connecting distant cities with single-aisle efficiency. The Flaw almost derailed the program, but it didn't break its fundamental business case. This story was never just about one fuel tank. It's a lesson for the entire aviation industry. In the post-737 MAX era, the rules have changed. Pushing the boundaries of design is no longer enough. Manufacturers must navigate a regulatory landscape that is more cautious and more demanding than ever before. The A321 XLR isn't just another aircraft. It's the first major test case of how innovation will work in this new world. Click here to check out our other videos.